In this video, we're going to focus on some problems where you have to find the area under the standard normal curve, and the problem requires finding the area, the total area, by combining two different areas. And I'll give you some examples. There's three different scenarios where this would happen. And so the first one would be if you want to find the area to the left of a positive z-score. So a positive z-score would be to the right of 0, and if you want to find the area to the left of that, it would be all of this area and then the entire right-hand side. And if you were using technology, software or calculator, you could do that all in one step. But since we're going to be using the z-score chart, the chart only gives us areas between 0 and the z-score. So we can get an area for this section right here, and then we can also get an area for this section. Now, keep in mind, we know that the area of an entire side of the curve is 50%. So we don't even have to use the chart for the left-hand side. But the z-score chart will give us the area for this section on the right. And so we'd have to add these areas together to find the total area. Now, the other scenario is if you wanted to find the area to the right of a negative z-score. So a negative z-score would be to the left of 0, and if you wanted to find the area to the right, it would be all of this area right here plus the entire right-hand side. And so we know that the entire right-hand side is 50%, which has an area of 0.5. I should have mentioned that before on my last picture. The area is 0.5. And then the chart can give us this area on the left-hand side. And so we have to piece those together and do them separately and then add them together. And then the final scenario would be if you wanted to find an area between a positive and negative z-score. So if you get a picture that looks like this, where you have some shading, so we're shading between these two z-scores, the chart cannot give us an area from this one z-score on the left all the way to the right. It can give us the area between 0 and a z-score. So it can give us, this would be one area the chart could give us, and then the chart could also give us this area over here, and then we would have to add those together. So let's jump in and do a problem or two so that we can see how this would actually work. Okay, so in example 3, we're going to draw a sketch and find the area of the given region. So we want to find the area to the left of z equals 1.95. So I've already got this graph here, and it's a great idea. You know, if you want to use these standard graphs, you could even print these off and use them if you don't want to draw them each time, but sketching one on your own is good too. So 1.95 is almost at 2, so I'm going to draw a line almost to 2 on the number line, and then we want the area to the left of that. So I'm going to shade everything to the left. And always look out for anytime you shade an entire side of the normal curve. So we've got 0 in the middle. The entire left-hand side is 50%. So we know that area, the decimal equivalent of that, is 0.5 or 0.50. So that side is done. What we need to do now is look up on the chart, what is the area between 0 and then z equals 1.95. So I'm going to pull up the chart, the normal area under standard normal distribution chart, and I am going to look for 1.95, a z-score of 1.95. So it looks like I have to scroll down to the next page, and I've got, oh, you know what, I think I scrolled too far down. Let me go up real quick. Looks like I've got 1.74, 1.75. Oh, nope, I gotta scroll down here. Sometimes it takes a minute. It looks like 1.95 is right here. And I've got an area of 0.474. So the area of this side is 0.474. So total, I'm going to add 0.500 plus 0.474, and you can use a calculator. I like to add some extra zeros on my after the 0.5, and that way it allows me to just easily add by hand. So my total area is 0.974. The percentage, if I move my decimal 2 spots to the right, that's also 97.4%. So if you're ever needing to find the percent, that's the percentage. And then looking at my picture, that looks reasonable because remember the area under the whole curve is 100%. So 97.4% means that most of it should be shaded, which it is. So that seems reasonable. All right, let's do another problem. Okay, in part B, I'm looking to find the area to the right of z equals negative 0.95. So I first draw a line or a tick mark where negative 0.95 would be. So negative is to the left of 0, and it's not quite to negative 1, so I'll draw a line about there. And so this represents negative 0.95. And then I want to shade to the right of that, so I'm going to shade all of this and then the entire right-hand side of the curve. And so anytime we've got the entire right-hand side of the curve, that area is 0.5 or 0.500. And then we have to find this other area using the chart. So the chart helps us find areas between 0 and a z-score. So if I look up 0.95, because remember the chart does not have negative values, but the curve is symmetric. So I could just look up the positive 0.95 and that'll give me the same area as what I need here. So I'm going to pull up the chart and I'm going to look up z equals 0.95. And so it looks like I should be right around here down at the bottom. And it looks like it has an area of 0.329. So I'm going to go back to my picture. So we've got an area of 0.329. So total, I'm going to add these together. I have 0.329 as the area on the left side, and then 0.5 or 0.500, that's the right side of the curve. And then I'm going to add these together and I get a total area of 0.829 or 82.9% if I convert that to a percentage. And then lastly, I'll do C. So we're going to do a problem where we have to find the area between two z's. So I'm going to draw a z value of 1.5, so in between 1 and 2. So 1.5, and then negative 1.75. And then I want to find the area between. And so what I'm going to do is I'm going to actually I'm going to do these separately because the z-score chart is only going to give me an area between 0 and a value, z-score. So I'm going to look up 1.5 and that'll give me this area. And then I'm also going to look up 1.75. So I'm going to start with 1.5. So I'm going to go to my chart and I'm going to look up 1.5, which looks like it's up here on the right hand side, an area of 0.433. So I'm going to label my picture. This area is 0.433. And then I'm going to go back to my chart and look up positive 1.75 because remember they're the same as negative 1.75. So I'm going to scroll down. Whoops, I'm going to go back here and just look for 1.75. And it's over here. And it's got an area, it says the area is 0.460. So I'm going to go back to my problem and label this left-hand side 0.460. So the total area is just going to be 0.460. That's the left-hand side of the picture. And then 0.433, which would be the right-hand side. And I can add these together and I get 0.893, and you can also put a 0 in front of that if you'd like. And as a percentage, if I move that decimal 2 spots to the right, we're looking at 89.3%. So 89.3% of values are going to be between z equals 1.5 and z equals negative 1.75. And remember that those z values are just the standard deviations away from the mean.